Have you ever wondered how the smallest particles in our universe behave? Welcome to the mind-bending world of quantum physics. Quantum physics, a term that might seem intimidating at first, is simply our best attempt to understand the universe at its most fundamental level. It's a fascinating field that breaks away from the conventional rules we're accustomed to in our everyday world. One of the cornerstone principles of quantum physics is probability. Unlike the deterministic world of classical physics, where we can predict the outcome of an event with certainty, quantum physics operates on the principles of chance. This means that we can only predict the likelihood of an event happening, not the exact outcome. Another key principle is discreteness. In the quantum realm, certain physical quantities, such as energy, exist in discrete or quantized amounts. This means they can only take on specific values and nothing in between. The relationship between objects is also central to quantum physics. It's a world where everything is connected, where particles can become entangled, meaning the state of one can instantaneously affect the state of another, no matter the distance between them. A common misconception about quantum physics is the role of the observer. It's often said that the act of observing an event determines its outcome. While it's true that measurements can affect the system being observed, it's important to note that the observer is just another physical system, subject to the same quantum laws. So, in the quantum world, particles can exist in multiple places at once until observed. Now let's dive deeper into this fascinating subject. Imagine firing particles at a screen with two slits. What do you think will happen? Now, let's dive into the double-slit experiment, a classic demonstration of quantum mechanics. Picture this. You have a gun that fires particles like electrons or photons towards a barrier with two slits, and beyond that, a detection screen. If these particles behaved only like particles, you'd expect to see two bands directly behind the slits, right? That's the classic Newtonian physics talking. But what we observe is quite different. We see an interference pattern, a set of alternating light and dark bands, as if the particles are behaving like waves. But here's where it gets even more mind-boggling. If we fire those particles one at a time, you'd think, they're particles after all, they'll just go through one slit or the other and form two bands. But no, the universe is much more mysterious. Even when fired individually, these particles still create an interference pattern over time. It's as if each particle is going through both slits simultaneously, interfering with itself and behaving like a wave. How could this be possible? Welcome to the quantum world. It's a world where particles can exist in multiple places at once, a state we call superposition. It's a world where reality is much stranger than anything we could dream up. Remember, this is not just some theoretical oddity. We can and have done these experiments, and every time we see the same spooky behavior, particles acting like waves, creating interference patterns, even when there's no possible way they could interfere with anything but themselves. And just when you think it can't get any stranger, we find that simply observing which slit the particle goes through changes the outcome. When we measure, we force the particle to choose a path and the interference pattern vanishes. This is known as the observer effect, a cornerstone of quantum mechanics. So this experiment shows that particles can behave like waves and pass through two slits simultaneously. Quite a brain twister, isn't it? And that, my friends, is just the tip of the quantum iceberg. So hold on tight as we delve deeper into the strange and wonderful world of quantum physics. Now that we've got a basic understanding of quantum mechanics, what's its relevance in today's world? Quantum physics, while a complex subject, has practical applications that touch our lives every day. Its principles are woven into the fabric of modern technology, powering advancements and discoveries that once seemed impossible. One such application is in the realm of electronics. The behavior of electrons in atoms and molecules, a key area of study in quantum physics, plays a pivotal role in the development of electronic devices. The quantum mechanical properties of these particles allow for the creation of more efficient and powerful electronic systems. Moreover, quantum physics is also making waves in the field of medicine. By understanding the quantum behavior of particles, scientists can develop more accurate disease diagnosis methods. For instance, the use of quantum principles in imaging techniques can provide unprecedented detail, potentially revolutionizing how we detect and treat diseases. Another fascinating development is the creation of attosecond pulses of light. This is an exceptionally brief flash, lasting only a few billionths of a billionth of a second. These pulses allow scientists to observe the rapid processes of electron movement and energy change, offering a window into the quantum world that was previously inaccessible. These are just a few examples of how quantum physics is shaping our world. As we continue to delve deeper into the quantum realm, we are sure to uncover even more remarkable phenomena and applications. Just as our Nobel laureates have shown, the possibilities with quantum physics are indeed endless. So, where do we go from here? What does the future hold for quantum physics? As we venture further into the 21st century, the potential future developments in quantum physics are as intriguing as they are groundbreaking. Quantum computing, for instance, promises a revolution in how we process information. By harnessing the power of quantum bits or qubits, these computers could perform calculations at speeds unimaginable with today's technology. Next up is quantum encryption. In a world where data security is paramount, quantum encryption could offer an unbreakable code. By taking advantage of the quantum principle of superposition, where particles can be in multiple states at once, we could create encryption keys that are nearly impossible to crack. And let's not forget quantum teleportation. Now, this isn't about beaming humans up like in Star Trek, but rather about the instant transfer of quantum information from one place to another. This could have profound implications for how we communicate and exchange data. But there's more. The concept of new physics is also emerging, referring to the rapid evolution of discoveries in quantum mechanics. With every passing year, we're gaining new insights, challenging old theories, and pushing the boundaries of what we thought was possible. So, as we stand on the brink of a new era, we find ourselves in a world where the rules of classical physics no longer apply. A world where particles can be in two places at once, where the act of observing changes the observed, and where the impossible becomes possible. The future of quantum physics is as uncertain and exciting as the particles it studies. One thing's for sure, it will continue to baffle and amaze us.